and welcome to your very first geometry lesson. This is our very first section in chapter 1, and if you look at it, the title is Understanding Points, Lines, and Planes. Now you say, why do I need to start there? I thought geometry was about shapes. It is, but if you think about what you need to create a shape, let's just say a triangle, for example. You need 3 points. They are actually what we call later our vertex points. You need some line segments to connect them. And where did you draw them? You drew all of that, the points and the lines, you drew them on a flat surface. And you would typically draw them on a piece of paper, or if I was in class, I would draw them on the board. But right here is the basis for your entire concept of geometry for us. It's our points, lines, and planes that we create the shapes. Okay, now let's take a look at the first concept here. There are 3 undefined terms in geometry. The 3 undefined, which means there is no set definition for them. We can describe them with characteristics, but there's no set definition. If you were to go to the glossary in your textbook, you wouldn't actually see a straightforward definition for them. They are, again, point, line, and plane. Now, let's look at the word point. Okay, a point. Okay, it has a location, but no size. Now, if you think about where you've seen points before, in algebra, you saw them on your coordinate plane, right? So for example here, you had the coordinate plane, right? Quadrant 1, 2, 3, and 4, and you could graph points. So for example, right here, this would be the point 1, 1. So right there, we'd have 1, 1, and that would represent a point right at that intersection there for 1, 1. So you've had points in the past. We're just going to look at them in a little bit of a different way in geometry here. So for a picture, it would maybe look something like this. There's no specific size to this, okay? There's no specific size that we need. It's usually just represented by a dot. Represented by a dot. Now, how do we name it? Okay, they are named by a single capital letter. So right here, we have point P. It's point P. All right, let's look at lines. In a line, okay, a line has no endpoints. Lines go on forever and ever, right? If you think about this line right here, the arrows on the end indicate that it goes on forever. Now, right now, you see 2 points on that line. You have to have at least 2 or you can't make a line. Think about it. If I only have 1, I can't make a line out of that. I need to have at least 2 to connect those to be able to make a line. Now, I have actually an infinite number on there. This extends forever in all directions, okay? But there are no endpoints for this. There's no beginning, there's no end. But I can actually have an infinite number, so there could be a whole bunch on here. There can be ones that you don't even see. So, as we said, it's made up of an infinite set of points. And for our purposes in geometry, all of our lines are going to be straight. No parabolas in geometry. We're not talking any curved lines here. Now, when we talk about this line right here, we say, okay, well, how are we going to name it? Well, I have 2 points on here, A and B. Lines are most often named by 2 capital letters. The 2 capital letters are actually any 2 points on the line. Any 2 points. It doesn't have to be the ones you see here in the beginning and the end. There could be more points, right? I could have another point C right here. All you have to do is pick any 2 you want to name this line. So for example, you might have a tendency to pick A and B because those are the ones that are closest to your arrows here. You could also call that BA, by the way. It doesn't matter what letter you start with. But you might choose to call this CA, or you might want to call it BC. You can just pick any 2, all right? Any 2 letters, any 2 points. Now, in this picture, you also see this weird symbol right here. This little weird symbol is actually a lowercase cursive L. All right, that is an alternate method. There's no dot under that. This is not a point. It's an alternate method to name lines. So another way we can name this line is we can call it line L. Now, that is a cursive L. A lot of times they'll use either a cursive letter or an italicized letter simply because they don't want to get it confused with any numbers. So for example, if I was to write out this line L, you might be confused and think that that's line 1. So they always kind of curve it or make it italicized so there's no confusion there. The one thing that you are never going to see is 3 or more letters together. Okay, you're never going to see that. So in this particular picture right here, one of the most common mistakes, people will say, oh yeah, that's line ACB, and they'll put this line on top. No way, okay? You can never ever do that. This is a no, okay? We do not want to name it with 3 letters. Only 2 letters, not 3. Okay, only 2. So you can name it by 2 points on the line, or you can name it by the single lowercase letter. Okay, that is the alternate option for naming lines, but not 3 letters. Okay, never use 3 letters. I'll make a note of that. Never use 3 letters. You should make a note of that too. Okay, never, never, never. All right, let's talk about a plane. A plane extends forever in all directions. Now, I said earlier, the plane is like the piece of paper you draw your shape on. The problem with that is that the piece of paper doesn't go on forever, right? It's bound by the edges of it. However, planes actually have no edges. So you have to think about a plane extending forever this way and forever this way. Think about like a wall in your house or in our classroom where that wall would just keep on going left and right, and it would keep on going up and down, and it would never end. That is the concept of a plane. And they're always flat. Planes are always flat surfaces. And of course, we said they extend forever in all directions. So even though you see it bound by edges, you have to keep in mind that the plane has no edges. Okay, that is super important. I know it looks like it does, but they actually do not. All right, now let's talk about all these letters you see in here. Some of them you're going to recognize as points, right? The dot next to it indicates a point. So F, G, and H, those are all points. What is this letter up here? Well, it's a V. If it looks like a V to you, that is exactly what it is. But if you notice, it has no dot next to it. There is no dot next to that. So if you focus on that for a second, that letter that has no dot next to it is the name of the plane. Okay, that's the name of the plane. So we could call that plane V there. The other way to name a plane, okay, again, so the first one is named by a single capital letter with no dot next to it, no point next to it. Okay, that's the first way. I would like to say that's the most common way. That's the way that you want to use first, okay, if you have it. You're not always going to have that though. So there has to be an alternate way to name it, and the alternate way is to name it by 3 points that are not in a line. So for example, right here, you have F, G, and H, and you cannot make a straight line to connect F, G, and H. I can connect F and G, right? But I can't make a straight line to connect F, G, and H. F and G, that straight line would be there, right? H, G would be here, but I can't make a single straight line to connect all 3 of them. So I could call this plane FGH. Okay, or you can call it GHF, HGF, whatever you want, just any 3 points. But they can't be in a line. Now, let's talk about why. So let's say I have a plane, and I have my points F, G, and H, and they are all in a straight line. I could actually connect those to make a straight line. Well, that's a problem. And let me explain why that's a problem. That is a problem because I could potentially have another plane that comes down here and cuts right through that. Okay, it can cut right through that plane. It's going to come down and cut right through. This yellow plane right here is cutting right through it. It's coming straight down. It's crossing through that line right there. Now the question then becomes, which plane are those 3 points on? Are they on the flat surface here, or are they on my yellow plane here? Well, technically the answer is they're on both. They're on both. So you never want to pick 3 points in a row because another plane could also contain those 3. But in this case, you can't have another plane contain them. I can come down and grab 2 of the points, right? But I'm not going to grab G in that, okay? If I come straight down, I'm not going to grab G. Same thing here. I can grab H and G, but I can't grab F. So you can see another plane can grab any 2 of them, but it's not going to be able to grab all 3 in this case. So you want to make sure you pick ones that are not in a line. Not in a line, the term we use for that is non-collinear. These 3 points, F, G, and H, they would be collinear. They would be on the same line, whereas F, G, and H up here are what we call non-collinear. They're not in a line, okay? All right, let's go on to the next concept. Next concept is going to be talking about line segments, different from a line. They're actually like part of a line, right? You could have a line segment. In fact, every line has a line segments living within it. And I say that because if you go back to this picture right here, I got a bunch of line segments in here. I have line segment AC. I have line segment CB. I have line segment AB, right? Line segments have a beginning and an end point. They have an exact length. We can actually measure it. We say it's a finite length. Okay, we can pull out our ruler and actually measure the length. And it has 2 endpoints. Lines do not have an endpoint. Lines go on forever. As we said before, there are 0 endpoints for a line, 0. Whereas the line segment has 2. Now, if you'll notice up here, you can call it a line segment or you can simply just call it a segment. Either one, it's your choice. All right, so let's look at this picture right here. In this picture right here, you see line segment XY, okay? And we're going to put the symbol on top. You've got to remember to put the line segment symbol on top, okay? There is a big difference between line segment XY and line XY. In this particular picture right here, this is line XY, okay? That's line XY. And we would name it like that. But from just here to here, that part right there, that is line segment XY. So those two are different. Line segment XY just represents this part, whereas line XY is the entire thing, all of it. So you have to be very, very careful with your symbols there. Difference between a line versus a line segment there. So just be careful. And again, like I said before, it doesn't matter the order of the letters. This could be line segment XY or line segment YX, either one. Okay, but it is always named by 2 endpoints with the segment symbol on top. Very important. Segment symbol is going to be on top there. As we mentioned about endpoints, these are the endpoints. They are the points at either at the end of a segment or array. Okay, so both of these, point F is an endpoint and point G is an endpoint, but they are always the points at one end. In this case, you have them at both ends of a segment or array. Okay, now let's talk about array. Array has only one endpoint, only one. It's got that one endpoint right there. It's also, to me, it looks like the starting point, right? But they call it an endpoint. And it extends forever in one direction, forever in one direction. The trickiest part is naming the array, right? So I am going this direction. I'm starting at R and I'm going towards Q. Starting at R and I'm going towards Q there. So we're going to name this Ray RQ because it starts at R and it goes towards Q. So you always start it with the endpoint first, but it has to have the ray symbol on top that points to the right. Points to the right there. So when I put that ray symbol on top, the arrow must point right. Okay? So in this particular case, if you had another point on there, let's say point S was on there as well, right? If you had point S that was on that line, or I'm sorry, on that ray, how do you know which one? Do you call it RS or do you call it RQ? Honestly, it doesn't matter. You could also call this RS, but again, the arrow must point right. It's heading in that direction. Arrows always point right. So regardless of if your ray is going up and down like this, right? If it's going down this way, if it's going to the right, it doesn't matter. The ray symbol always points right. Super important there, okay? All right, next part we're going to talk about is opposite rays. Opposite rays are always a pair of 2 rays. That is important. You can't have one opposite ray. You have to have 2, and they have a common endpoint. They also form a line. They look like a line. In this particular picture, we have a point F here, E, and G. So you're seeing 3 points on this particular line. So you can actually identify opposite rays in this picture. One of them would be E towards G, and the other one would be E towards F. Okay, they are opposite rays. They both start with E, and they go in opposite directions. So E has to be the letter that we start with. Both of them have to start with E. One goes towards F, one goes towards G. Arrow always points to the right. Be very careful with that. Now, what if you have more than 2 points on a line? What if you have 4 points? I'm sorry, what if you have more than 3 points on the line? What if you have 4? So here, I can have 4 points, E, F, G, and H, say, and I'm going to have more than 1 pair. Right now, if I have 3 points, I only have 1 pair of opposite rays. If I have 2 points on the line, I have no opposite rays. If I had just F and G, I can't name opposite rays there. You have to have 3 points to name opposite rays. You have to have 1 in the middle, and they have to be going in opposite directions. I do not have 3 there. You have to have at least 3, but if you have more, you end up with more pairs of opposite rays. So for example, in this case here, this case only has 1 pair of opposite rays. Okay, that has only 1 pair of opposite rays. But this one's going to have 2 pairs. 2 pairs of opposite rays. Okay, let's look at what they are. 1, again, we can start with E, and we can do E towards F, and we can do E towards H. So we have EF, again, arrow points right, and E towards H, arrow points right, always. But EH is also the same as EG, so you can pick whichever letter you want there. It doesn't matter. They are the exact same thing. EH and EG are the same exact ray. They're both heading to the right, starting with E, heading to the right. So it doesn't matter which one you pick. The second pair of opposite rays is going to start with the letter G. G towards H and G towards F. Right? So we have G towards H, arrow points right, and G towards F. And once again, before I said G towards F or G towards E, it doesn't matter. Okay, G towards E. They are the exact same ray because they are headed in the same direction. All right, now let's do a quick review. All right, so a point names a location, has no size. So example for us here is point P. Right, that's point P. A line is a straight path and extends forever in 2 directions. So for example, in this particular case, this is line AB. You could also call it BA, either one. Planes are flat surfaces that extend forever in all directions. In this particular case, we have no single capital letter in here with a dot without a dot. Remember on what we talked about on the previous page is that if you have a single capital letter with no dot next to it, you can call it by that name, plane V. But in this particular case, we don't have one of those. There's no single letter here. So we've got to go for the option of naming that plane with the 3 points that are not in a line. So M, O, and N are not in a line. And again, it doesn't matter the order of the letters there. You just have to pick 3 that are not in a line together. All right, now the next one is a segment. Okay, a segment is a part of a line. Okay, it's a part. And it consists of 2 points. It's got to have at least 2 points and all the points in between. And in this particular picture, you're only seeing 2 points on here. There could be an infinite number in between here. But this is segment FG. You can also call it GF. The end point is either one of these points here. And that is the point at the end of a segment or array. So point F, point G, they are both endpoints there. Okay, they are both endpoints there. All right, let's go to the next concept, which is the ray. All right, we have the ray up here. The ray is the part of the line that starts at one endpoint and goes forever in one direction. And remember, when you name these, you have to start with the endpoint, head in the direction, and arrow always points right. So we're going towards K, arrow always points right. And also opposite rays, as we said, are 2 rays that have a common endpoint and form a line. Okay, opposite rays, 2 rays, common endpoint, and they form a line. And we looked at the fact that basically it just looks like a line. So you can use the one from the other side, which was line AB. Oh, it's caught on my paper here. Line AB there. But you have to have 3 letters. So if I put a C in here, right, I have ray CB and ray CA. They are the opposite rays there. That would be an example. All right. Okay. Don't forget to fill in your blanks up here. Okay. All right. Now let's identify the following. In the first one here, you see this is point Y. The next one, we're going to name this line segment AB. You can also call it BA, either one. The next one is a ray. Of course, this one's a segment. The next one's array. Has to start with the endpoint P, oh, not R, P. To start with P and head towards Q. Head P towards Q, arrow points right. That's the only name you can give that one. In this particular picture, they want you to identify that. That is point T. It's an endpoint of that segment. Okay, so that was an endpoint in that one. In this one here, this is a line. This is line MN. We can also call it NM. Either or. Okay, you can name it either way there. It doesn't matter what letter you start with, and you only pick 2 letters. Remember, as I said, if there was a third letter here, let's say there was an O, you wouldn't use that. Okay, you'd only pick any 2 of those letters that are there to name the line. And the last one is a plain. The first thing you want to look for is the single capital letter without a dot. There is not one there. So you have to name it by 3 points that are not in a line. So let's call it, and it doesn't matter where you start, JKL. Okay, so there are your examples. If there's any part of this lesson that you didn't understand, go back and rewatch. Good luck.